Hello, grade 12s. I hope you're ready for a challenge today. This section is probably a bit boring by now. Sequences and series, applying formulae. We've done the same thing over and over again. So I thought I'd change it up this morning and keep you at the edge of your seat with this question. It's taken from the IEB 2016 paper, and it's very special to me because it is a question that it was my first year of teaching matrics in 2016, and after the exam everybody came running to me saying, "Ma'am, there was this question about Busi and Kanya, it was so difficult," and it was the 11th question in section B of the exam. So first of all, by that time you are going to be tired. It is going to be tricky, but the maths behind this kind of question is actually so easy. It's the skill you need is to be able to lay out on paper what is actually being asked of you, how to tackle a question like this. Right, let's read through it. It says there are 6 red cards and 1 black card in a box. Busi and Kanya take turns to draw a card at random from the box, with Busi being the first one to draw. The first person who draws the black card will win the game. Assume that the game can go on indefinitely. Remember, we looked at this word yesterday. The word indefinitely is what should spark an idea to perhaps use series, sum to infinity. Okay, indefinitely is a very special maths word. If the cards are drawn with replacement, nice, denominators stay the same, determine the probability that Kanya will win, showing all working. Now I know what you're saying, "Ma'am, why are you giving us a probability question when we're meant to be revising sequences and series?" Because the actual probability behind this question is of grade 11 level, so it's presumed that you know it. I've just repeated the question at the top of the slide so that we can refer back to its information. But when you are dealing with probability and you're not too sure what's going on, or especially if you're dealing with a card game or a winning or losing situation, the gut instinct should be to draw a tree diagram. Okay, the goal, what we need to somehow include on this tree diagram, is the fact that Kanya will win. That's our end goal, because that's the question. It's asking us to determine the probability that Kanya will win. Now let's think about this. If the question tells us that Busi is going to be the first one to draw, so my first element, or my first 2 branches of the tree diagram, are going to represent Busi's turn. And Busi can either win the game or lose the game. And if he wins, do you see how it says the first person who draws the black card will win the game? So if Busi wins, that's that. End of the game. Thank you very much. Let's all move on with our lives. But there's a very good possibility that Busi won't win. So over here, I could have said Busi loses, but in order to show that, to try and incorporate Kanya into this tree diagram, instead of saying Busi loses, I'm just saying Busi loses, which means Kanya now plays. Okay, so my 2 options is Busi wins or Kanya plays. Let's think about, if Kanya plays, then either Kanya can win or he could lose, right? So we can get Kanya wins, and if Kanya loses, then Busi plays, right? But look at the question. It's saying Kanya will win is what we're aiming for. And there we go. We have Kanya wins. So let's think about the path that is followed in order to get Kanya winning the game. So the first person who draws the black card will win the game. As you can see, there's 1 black card and 6 red cards. So what is the chance that Busi will win by drawing a black card on his first turn? It will be 1 out of a total number of cards. 6 and 1 makes 7 cards in total. So the chance that Busi wins first up is 1 out of 7. What is the chance that he will lose? The 2 fractions coming from the same starting point or vertex of the branches must always add up to 1. So the chances that Kanya gets a chance to play is going to be 6 out of 7, because the chance of Busi losing is 6 out of 7. Right, so we've got that value on that branch. Then, because we are replacing the cards, we still have 7 cards in the bag. So the chance that Kanya will win is 1 out of 7. And the chance that he will lose, in other words, the chance that the game continues and it's Bosie's turn, will be 6 out of 7. So let's pretend, what if Kanye won the first time he played? Then we would take this branch with the first 6 out of 7 and multiply it with the winning branch 1 out of 7. So the chance that Kanye wins first time is 6 out of 49 in total. Great. We are generating something here. The 6 out of 49 is the chance that Kanye wins on his first go. Maybe this could be a first term of a series. Then, if he lost, Bosie would play, and then Bosie could either win or lose, which means Kanye would play. So we carry on the branch. If Bosie wins, it's the end of the game. But if Bosie lost, Kanye plays, and then Kanye could possibly win, or he could continue the game, whereby it's Bosie's chance again. So let's have a look. What route would we have to take to get Kanye to win again? Let's fill in the fractions on the relevant branches. We've got all our fractions up until this point. Here we're at now. The chances of Bosie winning would be 6 out of... Oh, now let's see. We're following this branch along here. So we're starting at 6 out of 7. Then we're following the 6 out of 7 branch. Then we want to get a value for that branch. And then we need a value for that branch. And I think it's pretty straightforward that the values on the branches are always 1 out of 7 and 6 out of 7. So here we can get a value that represents the chance that Kanye will win on his second go. Right? Do you agree that it will be the probability of winning on the first go added to the probability of winning on the second go? But now, what is the probability of winning on the second go? We're going to follow the branches. You're going to go 6 out of 7 times 6 out of 7 times 6 out of 7 times 1 out of 7. So this over here represents the probability that Kanye will win on his second go. Can you see we are generating a sequence where our first term of our sequence is 6 out of 49 and our second term is 216 out of 2401. We could repeat this tree diagram indefinitely, but as you can see, we don't have time or space for that. So we've actually already got enough information to answer this question. And can you remember the question said this game can go on indefinitely? So what you need to write down, if you just see the word indefinitely and you're in doubt, write down the sum to infinity formula. Have a look. The chance that Kanye would win on his first go represents your first term. So we have a value for A. How do we get from our first term to our second term over here? I think it's quite clear. You can see 6 over 7 times 1 over 7 was multiplied by 6 over 7 twice in a row. So our ratio is 6 over 7 squared. So that's 36 out of 49. Or you could just do the actual dividing your term 2 by term number 1 to get your ratio. Okay, so that's where the 36 out of 49 comes from. And now we have enough information to substitute into the sum to infinity. We are adding all the probabilities. So this sum to infinity represents the probability of Kanye winning on his first go, added to the probability of Kanye winning on his second go, added to the probability of Kanye winning on his third attempt, added to the probability of Kanye winning on his fourth attempt, etc., etc., forever and ever. Amen. So if this game were to go on indefinitely and they played for 40 days and 40 nights, and you were to count how many times Kanye won, it would be boiled down to being 6 out of 13 times. And why is it 6 out of 13? Look at, you would think that they would be even, that the chances of Bosie winning should be the same as the chances of Kanye winning. But it's not, because Bosie was the lucky guy to have the first go. Obviously, if you can play first, there is a slight chance that you may win first. So that's why Bosie's chance to win would be 7 out of 13. Okay, mull this over, discuss it with each other, Ask me questions if you need to, but that's the lesson for the day, and I hope it challenged your brain, but I also hope it maybe tickled your fancy just a little bit.